Hi, welcome to this lecture of Biomathematics. In the last lecture, we have been discussing the idea of derivatives. We discussed functions and we also learned how to calculate what is the definition of derivative. In this lecture, we will go ahead and learn more about derivatives and how to calculate derivatives of certain functions. So, it is very simple, nothing complicated. So, we will learn in the simplest way how to calculate derivatives of many functions that we already learned. So, the lecture name is Functions and its Derivatives, and in this lecture we will discuss how to calculate derivatives of various functions. So, to briefly, before going to the details of how to calculate derivatives, we will quickly revisit main important points of last lecture, which is first we learned this, that slope, the derivative is dy by dx, is nothing but how that function y changes with respect to x. So, as you can see here, you have y and x, and if you change x by a quantity dx, how much the y changes, that is measured by this ratio dy by dx, and we call it derivative of y. So, and we also learned that the finding derivative is like finding the slope of the function. So, let us understand this a bit more carefully. So, we had some function. So, let us plot it here. So, we had some function which was linear, and we wanted to get the derivative. So, we took some point x1 on x axis. So, this is x y axis and another point x 2, and we calculated what is the corresponding y points. This is y 1 and y 2. So, for x 1 there is a corresponding y point y 1, for x 2 there is a corresponding y point y 2. So, and we said that the derivative of y with respect to x, so we call it dy by dx. That is how much y will change if we change x by a quantity dx. So, what is the dx? Dx here is nothing but change in x, which is x 2 minus x 1, and the corresponding y is y 2 minus y 1. So, this is dy by dx, y 2 minus y 1 divided by x 2 minus x 1. So, this is the derivative, and this is also the slope of this straight line. So, this is what we mean by derivative. We can also express this in another way. This is also, so some books you will see this written in a different way, and that is y at this point x 2. So, this y corresponding to s 2 is y 2 minus y corresponding to x 1 divided by x 2 minus x 1. So, what does it mean? Let us understand this a bit more. So, y 2 is nothing but y corresponding to x 2. For x 2, for a value x 2, what is the corresponding y value? That is, y of x 2 means the y value corresponding to the x value x 2. And if you subtract from that the y corresponding to x 1 and divided by the change in x 2 minus x 1, you get dy by dx. So, this is all the same thing, but it can be written in different ways. So, in some books you will see it in a different way. So, one of the important rules while doing derivatives that you should remember is that if you look at here this quantity x 2 minus x 1. So, this is so the smaller this the x 1, the closer the x 1 and x 2, the better this definition of derivative. So, strictly speaking, the definition of dy by dx. So, let me write it here. So, dy by dx is equal to y of x 2 minus y of x 1 divided by x 2 minus x 1. So, now x 2 minus x 1, let me call x 2 minus x 1 equal to dx. this is change in x. So, this is dy by dx. So, you can also write this. So, if you just look at this curve we had here, so we had a straight line. So, if you look at this 2 points on x axis and 2 points on y axis. So, now I can call this x and this x plus dx. So, because this and you can call this y at x, y value corresponding to the x value, and I can call this y corresponding to x plus dx. So, you can also write this definition in a different way. So, I can write dy by dx equal to the y of x2 minus y of x1, which is like y of x plus dx, which is this point, minus this point, y of x. Again, this is nothing but this distance divided by x plus dx, which is this, minus x. In other words, y of x plus dx minus y of x divided by dx. So, this is another way of writing the derivative. Now, this is strictly speaking, we would like to have the dx very small. That is, the more closer these 2 points are, the better this definition is. So, the mathematically accurate definition is dy by dx is when dx is very small. When dx is very small. So, we want this, the more the closer, the more accurate this will be. So, we want this dx to be very small, so that the definition is proper, but for a straight line it does not matter the value of dx, but for complicated curves, the closer you take these 2 values in the x axis, the proper correct derivative one would get. So, strictly speaking, the definition of dy by dx is, mathematically they call limit dx going to 0. That means, the dx gets smaller and smaller, like as small as very close to 0. So, this dx arrow 0 means when the dx is very small, close to 0, y of x plus dx minus y of x divided by dx. So, this is the definition of derivative. Essentially, what we learnt now, this is the same thing that we have been discussing, but just that we should take the dx very small. That means, if you want to find the derivative of this curve at any point, so let us say you want to find this derivative or slope of this curve around this point, we should take 2 x values very close to each other, like very close to each other. This dx, the smaller the better it is, and the corresponding y values you calculate, and if you calculate the dy by dx, you get the slope, and this is the derivative. So, since we are trying to understand more about the biological significance and how this can be applied in biology, we wouldn't really go in detail into this technicalities of this definitions, but just keep in mind that whenever you find the slope, whenever you find dy by dx, take the x values as close as you can. So, this is just, once you keep this in mind, as we go ahead, we will keep this in mind, and whenever we calculate the derivative, we will keep this x values as close as we can. Okay, so now let us again look a little more to this what we have. So, as we see here, dy by dx we can calculate by noting down the dy and the dx, and we saw last time that whether you take dx here or here for a straight line, you always get the same slope. So, the dy by dx, if you take this dx around this 3 between 3 and 4 or some other point 7 and 8, you will always get slope equal to 1. That means, where you take along the x-axis doesn't matter, as long when you find the slope of a y equal to x curve, or when you find the slope of a straight line, doesn't matter where you take the slope, it is always a constant. This is a property only for a straight line. This you can see this by trying it yourself. But if you take another curve like y equal to x square, which is not a straight line, which is a curved function, you will see that if you take between 3 and 4, you will get one answer, and you will get, when you take between 7 and 8, you will get different slope. So the slope here is different from the slope. The slope here is different from the slope here. So what does it mean is that the slope changes as you go along the curve. So as you go along the x-axis, the slope of a curved line, so slope of a quadratic function y equal to x square function changes. In other words, the slope itself depends on the x value. So now the slope of x square is 2 times x. This is something which we learn by just trying out this by drawing this. We tried out. Last time we took 3, the corresponding value was 9, 4, the corresponding value was 16. So we found that 16 by 9. So we calculated all these values, and we found that slope of x square is 2x. And we also learned that finding derivative of a function is nothing but calculating how y changes with x, and in most physical situations, slope of a function represents some physical quantity. For example, velocity was one quantity we discussed last time. We will discuss more and more quantities, but today we will learn how to calculate the derivative of various functions. So the only function or 2 functions we learned so far how to calculate derivatives are y equal to x, which we found as a constant slope, and y equal to x square. Now we know many functions, and it's all very simple to calculate the slope of all these functions. We have to remember just 2 things. If you remember just 2 things, you can calculate derivatives of many functions. So when we started to study functions, we just learned couple of functions. We learned x, x square, x cube, etc. and we wrote all of the functions as some combination of this. Similarly, we will do a trick. We have to just learn the derivative of 1 or 2 functions, and then we are done. We can just use this derivative definitions and then see how other functions calculate the derivatives of other functions. So let us learn a simple rule of derivative, and then in fact 2 rules we will learn. So and we will use those 2 rules and then calculate derivatives of many functions. So this is so simple, much simpler than many other things you would learn in biology. So just the first thing you should learn is derivatives of x power n. So you had x, x square, x cube. So n is any number. So x could be 0, 1, 2, 3, 4. So whenever you have a function y equal to x power n, what is the derivative? What is the dy by dx? So this is the first thing you should learn, and the rule is that the derivative of x power n is n x power n minus 1. So let us take some examples. So we already saw some examples. So we already saw the first one. So when n equal to 1, x power n is x. So the derivative of x is 1. So let us see this. We know that x power n when n equal to 1, x power n is x, and dx by dx is 1. This much we know. This is a simple idea, right? The dx by dx. So instead of y, so y is x power n, and it's equal to x for n equal to 1. So y equal to x power n. This gives you x for n equal to 1. When n equal to 1, y is x, and we want to calculate dy by dx. which is equal to dx by dx, and this is 1. So, this is essentially the slope of a line y equal to x. So, this is y equal to x, and the slope of this line is 1, any point you calculate. So, now let us see if this applies to this our rule. So, the rule we learned today is that d by dx of x power n is n x power n minus 1. So, when n equal to 1, what is this? What is n x power n minus 1? N x power n minus 1 is 1, n is 1, x power n minus 1 is 1 minus 1, which is 1 x power 0. X power 0 is 1, so this is just 1. So, as according to the rule we learned, the simplest function, which is y equal to x, has a derivative which is a constant. Now, let us look at this another function, the next function, y equal to x square. So, now the rule is that dy by dx is n x power n minus 1. Here n is 2 because x power n. So, n is 2. So, that means dy by dx is n, which is 2, x power 2 minus 1, which is 2 into x power 1, which is 2x. So, derivative of x square is nothing but 2 times x. So, this is the application of this rule when n equal to 2. Let us apply this rule when n is equal to 3. So, now let us say the next case, n is equal to 3. That means y is x power 3, dy by dx, according to the rule we learned, dy by dx is n x power n minus 1. So, n is 3. So, 3 x power 3 minus 1, which is 3 times x square. So, d by dx of x cube is 3 times x square. So, we learned this much. So, once we understand this rule, we can use this many at different places and then learn derivatives of many other functions. Because as we know, many functions are combinations of x, x square, x cube, etc. So, now according to this rule, let us also see what happens when n equal to 0. So, let us look at this. So, let us look at what happens when n equal to 0. What does n equal to 0 means? N equal to 0 means y is x power 0. X power 0 is 1. So, when y equal to 1, what is dy by dx? This is n x power n minus 1. So, this is n is 0. So, 0 times x power n minus 1. 0 times anything is 0. So, the answer is 0. So, derivative of 1 is 0. It can be generalized that derivative of any constant is 0. So, derivative of any constant k is 0, where k is any constant, any number. So, derivative of any number is 0. This can be, again, we are not learning anything new, we just applied the rule we learned. So, the rule we learned, as we see here, is that d by dx of x power n is n x power n minus 1. This is the golden rule that we should remember. once we remember this, whatever we said so far all follows from this just one line. So, if we just remember this one line, everything we saw so far in this lecture all follows from this just one rule. Now, let us also just learn a bit more, slight variation of this. So, let us say y is equal to 3x. Then what happens when y equal to 3x? So, we have to find out dy by dx. So, according to this rule, we can, so it turns out that we will tell this details of this rule later, but it turns out that the derivative of, you can keep this constant there and 3 dx by dx. So, this is 3. So, you can keep the constant there and calculate the derivative of this function, and then that is the answer. So, in other words, we can extend this to many other things. Let us say y is in general k x power n, where k is a constant and n is the number which is 1, 2, 3, 4 that we saw so far, and x is the x variable that we took. Then the dy by dx, and it turns out that this is equal to, you keep the k there and then d by dx of x power n, and we know that what is d by dx of x power n. So, we know what this is. This is nothing but k times n x power n minus 1. According to what we learned so far, d by dx of x power n is n x power n minus 1. So, the dy by dx of k x power n is k times n times x power n minus 1. So, this is a simple extension of the rule what we learned, that whether you multiply, when you multiply with a constant, it does not matter, that constant just stands there and you find the derivative of the function. So, this is a constant times any function. So, the constant stays there and you find the derivative of the function. That is the rule in mathematics. Now, let us look at the next rule. So, there is one more thing which we should learn. So, the first rule so let me reiterate the rule. First rule we learned, that the generalized dy by dx, when y is k times x power n, dy by dx is k times n x power n minus 1. This is what we learn now. Now, let us look some other simple functions, like what happens if y is sum of two functions, x square plus x power 7. Because we learned many functions which are some combinations of x, x square, x cube, x power, everything. So, what happens when these two functions, when y is a sum of two functions, right? So, what happens when y is sum of two functions? It turns out that the derivative is equal to, you can find this derivative of this and this separately and sum them. So, the derivative of the first quantity. So, this is the derivative of this function plus the derivative of the second function. And this is the answer. So, when you want to find out derivatives of two functions, derivative of sum of two functions, you can find the derivative of each function and sum them. So, in general, we can write this like what I wrote here. So, if you want to find out the derivative of two functions f of x and g of x, so this is, we can call this f of x. So, this x power 7, I call this f of x, some function f of x, x power 2, and this I call some other function g of x, and this is f of x plus g of x is this sum of these two things, and the derivative of this is equal to the derivative of the first function plus the derivative of the second function. So, this is the second rule that you should learn. So, there are two rules which you should learn: derivative of x power n and derivatives of sum of two functions. If you know this much, this is enough to learn many things. So, let me just write down this two things once more. So, let me just write down this two things once more. The two rules we should learn. Rule 1 is that derivative of x power n, d by dx of x power n is n x power n minus 1. The second one you should learn is that derivative of sum of two functions. If you want to find out derivative of sum of two functions, so x power 7 plus x power 9. This is derivative of x power 7 plus derivative of x power 9. So, this is the second rule. Derivative of, so this rule, if I write in words, this says derivative of sum of two functions is equal to sum of their derivatives. So, this is what we saw. So, derivative of two functions, sum of two functions x power 7 and x power 9, those are two functions, and if we want to find the derivative of this sum, if you want to calculate that, we can take the derivatives of this individual functions separately and sum them. So, derivative of sum of two functions is equal to the sum of their derivatives. So, these are the sum of their derivatives. So, this is the first derivative, second derivative, sum of these two, you get the answer. So, if we know these two things, this is enough for us to learn many things. So, we will go ahead and see a few things. So, as we saw, if we know these two rules, as we this rules written here, if we know these two rules, rule 1 and rule 2, we can calculate derivatives of many functions. And let us take the example of the exponential function. So, let us look at here. So, the exponential function e power x is nothing but 1 plus x square by 2 plus x cube by 6 plus x power 4 by 24 plus x power 5 by 25 plus so on and so forth up to infinity. So, this is sum of infinite terms, and let us say you want to find out the derivative of this. So, now why I am reaching to e power x is that this is important. If we want to calculate derivatives of some functions in biology like growth processes or decay processes, many of these processes are represented by exponential functions, and one should understand this exponential function. We saw 2 power x as examples of bacterial growth. We saw 10 power x related to log. So, many of these functions are very much used in biology, and if you want to calculate some physical quantities from that, one should understand how to calculate the slope of these functions. So, that is why I am reaching to this e power x. That is why I want to teach you, I want to slowly take you to this e power x and functions which is used very often in biology, like sin x, cos x. They are periodic functions which is used to represent many phenomena, biological phenomena, like we have many functions that repeat, many things that repeat periodically in our day to day life as well as in biology. So, that is why I want to take you to e power x. So, as we know, e power x is nothing but, so let me write this here. E power x is 1 plus x square by 2 plus x cube by 6. 6 can be written as 2 into 3 plus x power 4 by 24. 24 can be written as 2 into 3 into 4. This is 24 plus so on and so forth. This is the definition of e power x. Now, let us calculate the derivative of e power x, that means d by dx of e power x. This is what we want to calculate. That means we want to calculate derivatives of. So, now what is e power x is sum of all these functions. So, 1 minute ago we learned this important rule that derivative of sum of two functions is nothing but sum of their derivatives. So, let us just go and learn this rule quickly. So, what we learned here is that derivative of sum of two functions is equal to sum of their derivatives. So, instead of, if you want to find out derivatives of this sum, what we should do is that we should find the derivatives of each of them and sum them. Simple. So, we know what is the derivative of 1, we know what is the derivative of x, we can find out what is the derivative of x square, we can find out what is the derivative of x cube, we can find out what is the derivative of x power 4, and so on and so forth, and we can sum them and we will get the derivative of e power x. So, let us try and do this. So, first let us find the derivative of 1. So, to do this we will, so just a few minutes ago we saw, so the next rule, the first rule we learned will be using here. The rule we saw is that d by dx of x power n is n x power n minus 1. So, we will write this rule here in the side here. So, d by dx of x power n is equal to n x power n minus 1. Or let me write this rule here at the bottom so that it is clear. So, rule is that d by dx of x power n is n x power n minus 1. So, when n is equal to 0, you get x power 0, which is 1, and derivatives of 1 is 0. So, derivative of 1 is 0. So, this is the derivative corresponding to 1. Now, the derivative of x. So, what is derivative of x? X is nothing but when n equal to 1. When n equal to 1, this is 1 x power 1 minus 1 0. So, derivative of x is nothing but just 1. Now, what is the derivative of x square by 2? Derivative of x square by 2. So, derivative of x square is, so 1 by 2 is a constant. So, we will keep this constant as it is, 1 by 2. And derivative of x square according to this rule is 2x. So, this is 2x. Now, what is the derivative of x cube? Derivative of x cube is 3x square. And whatever the denominator remains, 2 times 3. What is derivative of x power 4? It is 4x power x cube 3. According to this rule, it is 4x power 3. And whatever the denominator remains that way, plus so on and so forth. So, let us rewrite this. So, 0 is 0 plus anything is that itself. So, we need not write 0. So, we can write 1 here. So, this is essentially 1 plus this 2 and this 2 cancels. So, essentially you get x, this 3 and this 3 cancels. So, you get plus x square by 2, this 4 and this 4 cancels. So, you get x cube by 2 into 3 plus so on and so forth. So, you can keep doing this sum. So, what did we get finally? So, let us compare what we got here and what we had here. So, we got 1 plus x square plus x cube by 2 into 3 and so on. And what do we have here? 1 plus x square by 2 plus x cube by 2 into 3 and so on. So, this and this are exactly the same. If we just take the next term, x power 5 term here, and find the derivative, you will get this. So, since this is an infinite term, you will get exactly this as this. What does this mean? This means is that derivatives of e power x is e power x itself. So, so this is one thing we learn. We learn that derivative of e power x is e power x itself. So, this is an exercise for you, that what you should do. Whatever I wrote here, you should take a paper and take many terms up to 20, up to x power 20, and try out, take any textbook of mathematics or even the logarithm, the tables we have, and find out the exponential function for many terms, 5, 6, 7, 8, 9 terms, up to 10 terms maybe, and then calculate the derivatives according to these two rules we know, and see what you get, and you will get that d by dx of e power x is e power x itself. So, you will get that whatever you start with is the same thing you end up with. So, you should take this and use these two rules we learn and convince yourself that derivative of e power x is e power x. So, the only way you can learn is this, that take a paper and do it yourself. Then only you will be convinced. Once you are convinced, it is very simple, like you get much better feeling. So, what does this graphically means? Derivative of e power x is e power x, what does it graphically means? So, slope, derivative is slope. So, slope of e power x is e power x itself. So, what does this mean? This means is that, so we all know that e power x, if you plot, looks like some function which increases very fast. So, now if you find the slope at any point x, if you find the slope is e power x itself. You calculate e times e power, that the slope at any point is same as that function itself. That is what it means. So, this is also you can try, you can draw an exponential curve, calculate the slope at different points. So, take a graph sheet, draw e power x yourself, go to a point and calculate the slope there, calculate dy by dx. So, calculate the slope there, calculate, this is dy and this is dx, and calculate the dy by dx, and it will be e power x. So, take some other point, calculate dy by dx, you will get the value e power x. So, you should try this graphically and convince yourself also that derivative of e power x is e power x itself. Now, the next thing we should learn is derivative of e power minus x. So, once we know e power x, we can easily learn e power minus x. So, let us look here. E power minus x is nothing but 1 minus x plus x square by 2 minus x cube by 6 plus x power 4 by 24 by minus x power 5 by 120 and so on and so forth. So, if we know this sum, just like what we did before, we can calculate the derivative. So, you can calculate the derivative of each of this term and then sum of all them, and you will get the derivative of e power x. So, let us quickly try doing this also. So, let us just quickly do this. E power minus x is 1 minus x plus x square by 2 minus x cube by 6, 6 is 2 times 3 plus x power 4 by 24, 24 is 2 times 3 times 4 minus x power 5 divided by 120. 120 turns out to be 2 times 3 times 4 times 5. So, now if you find out the derivative of this, so you want to find out d by dx of e power minus x. So, you can find out the derivative of each of this term. So, derivative of 1 is 0. This is the derivative of 1, and you have minus derivative of x is 1, derivative of x square is 2x. So, you have plus derivative of x square is 2x, you have divided by 2. Derivative of x cube, so minus sign, I repeat that, and derivative of x cube is 3x power 2 n x power n minus 1, where n equal to 3, divided by 2 into 3, plus x power 4 is, derivative of x power 4 is 4 x power 4 minus 3, which is 4 minus 1, which is 3, divided by 2 into 3 into 4, plus so on and so forth. Actually, it's minus here, the next term is minus. So, the plus and minus will keep repeating and it will go, the terms will continue. So, now if we rewrite this, what do we get? We get first term is minus 1, the second term is this 2 and this 2 cancel, so it is just plus x. And the third term is this 3 and this 3 cancel, so you have minus x square by 2. And the next term, this 4 and this 4 cancels, and what you have is plus x cube by 2 into 3, and so on and so forth. So, if you compare this and this, what do we get? You have 1 here, minus 1 here, minus x here, plus x here, plus x square by 2 here, minus x square by 2 here, minus x cube divided by 2 into 3 here, plus x cube divided by 2 into 3 here. So, what you have at the bottom is nothing but whatever here multiply with a negative sign. So, it turns out that this is nothing but minus e power minus x. Whatever was there, multiply with a minus 1. So, you multiply all this term with minus 1, you get minus e power minus x. So, it turns out the derivative of e power minus x is minus e power minus x. So, this is another thing which we can learn just by learning the two rules we said, that derivative of x power n is n x power n minus 1, and that the derivative of sum of many terms is nothing but sums of their derivatives. Simple. So, now one can generalize this and write little more general thing, that derivative of e power kx. So, if y is e power kx, derivative of y, which is dy by dx, and it turns out that it is k e power kx. So, you will learn this. So, you should convince yourself that this is true, but this is the derivative of e power kx, where k is any number, and the derivative you get is k e power kx, where k could be minus 1. That is what we saw. When k is minus 1, e power kx is e power minus 1. When k is plus 1, e power kx is e power x. When k is 2, e power 2x, and the derivative is 2 e power 2x. So, derivative of e power 2x is 2 e power 2x. That is what this means. So, this is the general rule. So, using this idea, now we will learn derivatives of few more other functions, like the periodic functions we learned in biology, like sin x and cos x, and we will stop today's lecture after that. So, let us learn derivative of two more functions quickly, sin x and cos x. So, we will quickly just mention the derivative of sin x and cos x, and then we, in the next class, we will in detail we will show that the derivative, how exactly one can get these derivatives and what does this mean. So the derivative, so we, as you see here, last time we had seen this, the functions sin x and cos x, they are periodic functions, and they can also be written as sum of sum of series of x, x square, x cube, etc., etc. So, basically sin x is x minus x cube by 6 plus x power 5 by 120 minus x power 7 by 5040 plus so on and so forth. And the cos x is 1 minus x square by 2 plus x power 4 by 24 minus x power 6 by 720 and so on and so forth. And it turns out that the derivative of sin x is nothing but cos x, and derivative of cos x is minus sin x. So, this derivative of this function is this function, and derivative of this function is negative of this function. So, this you can convince yourself. You can just take this, and just like what we did now, take this sum, take this series and find derivative of each terms using these two rules we learned. We have to just use these two rules, that for first that you have to find individual derivatives and sum them, and the other rule that derivative of x power n is n x power n minus 1. If we use these two rules, we can find the derivative of sin x and cos x, and you will see that sin x derivative is nothing but cos x, and the derivative of cos x is minus of sin x. You should do this and convince yourself, and in the next lecture we will discuss what is the significance of this, and graphically representing this sin x and cos x and the derivative. What does it mean? Does it have some other meaning, physical meaning, etc.? We will discuss, but for the moment you should learn how to calculate this mathematically and how to write down these derivatives, and once you know this, we will learn the significance of this in the next lecture. So, to summarize today's lecture, we should just revisit those two rules which we saw. So, these are the two rules which we learned, and we can revisit these two rules as a summary of today's lecture. The take home message, the things that you should take home from today's lecture is that the derivative of x power n is n x power n minus 1, and derivative of sum of functions x is basically sums of their derivatives. So, if you just know these two rules, rule 1 and rule 2, you can calculate the derivatives of many known functions, and we will use this in the next class to learn many more functions. So, we will stop here today.